I made my own version of the Chrome T-Rex game in Godot. While I kept the gameplay very similar, I changed up the graphics using some open source images from itch.io. There were three main game mechanics that I needed to work out: a parallax scrolling background, physics for the dinosaur to be able to jump over the obstacles, and an obstacle spawner with collision detection. So first, onto the parallax background. This works by splitting the background image into multiple layers and then placing the layers over each other. Each layer moves at a different speed, with the furthest away layer moving slowly and the nearest layer moving fastest, to give this 3D background effect. For this, I use Godot's Parallax Background and Parallax Layer nodes. In Godot, I begin with a new scene and I create my first node. This is going to be a Parallax Background node. I rename it to BG and then I can start adding the different layers. The first layer is just a solid green image, and for that I can use a Sprite 2D node. I drag over this first layer into the texture, and the only thing I change here is to untick this center property. This puts the green image right in the middle of the screen. This one doesn't need to scroll, but the other ones do, so I'm going to create additional child nodes here, and these will be parallax layers. Each layer then has its own Sprite 2D node. This node is what contains the image for that layer. I drag over PLX2 into this texture property and again just untick the centered value. To give the impression of an infinitely scrolling image, we go back into the parallax layer node and under motion we add mirroring. Now I need to know how wide this image is first of all. So if I go back to the texture and I select it, it will tell me that it's 1152 pixels wide. I can put that into this mirroring X property, and now you can see that it's created a second image to the right. Now as this one scrolls, the second one is going to take its place and just give us the impression of continuously moving backgrounds. The backgrounds that are furthest away, like this one, have to move slower than the other ones, and that's where this motion scale comes in. Make sure that X and Y aren't linked by unticking this little chain here, and set this value to something less than 1. I will use 0.6. I can then duplicate these two nodes by selecting this option or highlighting them both and press Ctrl and D. I do this 4 times and then I go through each of my sprites and I replace the texture with a new one. So I'll update this one, the 4th one, and then lastly the 5th one. And with that you can see that we've now filled out the entire background. However, all of the parallax layers currently move at the same scale because I duplicated them. This first one, which is the furthest one away, is at 0.6. I'm going to go through them all and increase them by 0.1 for each of them. So as we get closer, they move slightly faster. And then the last one will be 0.9. And that's it for this scene. So I can go up here and make sure that I save it inside my scenes folder. Next, I set up the dinosaur scene and add in the jumping physics. The dinosaur will be a character body 2D node, because that node is specific to user-controlled bodies. I will use this sprite sheet for animating it, which will be done by the animated sprite node. Then a couple of collision shapes are added, one for when a dinosaur is running and one for when it ducks down. And lastly, I'll play a jumping sound effect using the audio stream player node. So set up your scene in the same way, and this is how your node tree should look at the end. Just bear in mind that I've renamed some of the nodes here. Now I can begin configuring these nodes and clear these warning signs. The first one I'm going to begin with is the animated sprite, and that will give the player an actual image to use. The animated sprite node has an animation property here which contains our sprite frames. I need to go in and first create a new set of sprite frames, and when I click on it again, it brings up this animation panel down here. This is where I can configure the different animations that I want to use. So let's take a look at the sprite sheet. The sprite sheet I'm using has all the images in a long line, and these are the animations that it contains. There's the idle animation, running, jumping, taking damage, and lastly the ducking animation. I'm not going to use all of these images, so for jumping I only use one still frame. I don't use the take damage or the hurt animation, and for the ducking down animation I skip out that first image. Now I can begin setting up the animations in Godot. I'll start with the idle animation, so I rename this one to idle, and then I click on this icon here which says add frames from sprite sheet. My sprite sheet is inside the assets folder and then img, and it's called more.png. When I click this, you'll see that it's already split into 4 rows and 4 columns because that's what is defined up here by default. I actually have 24 frames and they're all in one line. Now you can see each of the frames is split up into its own tile. The idle animation, if I just zoom in over here, is the first 4 tiles. So if I select these first 4, or frames rather, if I select these first 4, I can add them into my animation. Now I can zoom in here and I can actually see the image has appeared. It's very small right now though, so I'm going to scale the whole thing up. I'm going to do that at the main parent node. So if I go into the Dino node here and I look for my transform, I can change the scale to 8 times. Now the image is much bigger, but you'll notice it's a little bit blurry. If we go back into our animated sprite, there's an option here under texture to change the filter from inherit to nearest, and that will sharpen the image back up again. I can test this animation out. I have some controls down here, and if I click play, it's going to start running through the animation. I can change the speed of it because that's a little bit slow for me. I can change that to 10 frames. And now it's going to run twice as fast. This icon here allows me to add more animations. Now see if you can set up the rest of the animations yourself. The steps will be the same as for the idle animation, you just need to select the appropriate frames from the sprite sheet. Once you've finished, you should have 4 of these animations set up. Remember to change all of them to 10 frames per second so that they run at the same speed. The last thing to do with the animations is to pick one of them that will start to play when the game begins, and that's going to be the idle one. So I select idle and I click this little autoplay button. And now I can configure my 2 collision shapes. So the first collision shape is going to be for the running state. I change the animation over to run and I go into this collision shape. On the right, I select a rectangular shape and I just adjust the size. You can turn on snap up here to make it a little bit easier. So I just capture the left side and up to the stomach. I don't really include the head, and then I go all the way to the feet and all the way to the head. And I can then repeat for the other collision shape. But before I create this one, I need to change my image over to the duck image. Now I go back in here and I create a new collision shape, which is another rectangle. I need to start it at the same point as the last one, so it doesn't go to the new feet, it goes to the previous feet. Then I pull the side in just like before, pull the head in just like before, but for the height, I just bring it down to where the new head position is going to be. During the game, I can toggle these 2 collision shapes on and off, so that when the player ducks down, it can get underneath some of the obstacles. And the last thing for setting up this scene is our sound effect. So I go in here, and I just need to drag over my sound, which is jump, over into my stream. Now this sound effect I'm not going to play right now, it's very loud, so I had to reduce the volume and I set it to -25. I didn't want it to become an annoying sound every time you jump, so it's just kind of in the background. And that's it for the dinosaur scene for now. So you can save this one just like the other one inside our scenes folder. Now I need to create the ground that the dinosaur is going to run and jump on top of. I've created a new scene and set up the node tree already, so you can configure yours in the same way. The parent is going to be a static body 2D, and we don't have to change anything here. On the sprite, we just need to add in the image of the ground. That is underneath background and is ground.png. We drag it over here, then untick centered, and just adjust the transform to move the ground down to the bottom of our game window. The position for that is 552. The game window is a little bit difficult to make out, so I'm going to turn off these grid lines. And now you can see this purple outline is our game window. The ground is twice as wide. I'm not using the parallax layer for the ground. Instead, I'm doing the parallax scrolling myself using code. And that means I need an image that's twice as wide as my game window. And the last thing to do is create a collision shape. This is going to be another rectangle, and we just drag it down to fit the entire size of our ground image. And for this, I can turn on the snapping again just to make it a little bit easier to adjust it. So that takes care of one side, and then I just extend it over to the other. And that's the ground done, so I'm going to rename the parent node to ground, and then I save this scene together with the other ones in that scenes folder. And now we can start pulling those things together. I create a new scene, and I create a new node inside of it. This one is going to be our main scene with our main node, so I renamed that one to match. I'll hide the grid again just to make it a bit more visible, and now I can start pulling through those other scenes that we've created. If I use this link up here, I can instantiate the scenes. I'll bring through our parallax background, there it is there. Then I'll bring through the ground, And lastly, I can bring in through the dinosaur. We can move the dinosaur to position it closer to where we want the game to start. The last node that I need to add is a camera 2D node. This node will follow the player as we scroll across this map, but you can see that it's not positioned in the same place. So I go into the transform property and I adjust this to be half of the screen width and half of the screen height. Now the camera is positioned perfectly over the game window. I can now save this scene and I can actually test it out at this point. If I press F5 and I select the current scene, it will run the game for us. And now you can see we've got our idle animation running, we've got the background and we've got the ground. The order of these nodes is important. If I was to move the dinosaur down a little bit and then move it behind the ground, you'll see that the feet disappear. Now this is going to be a problem later on because I'm going to add obstacles in code. So the obstacles will always be at the bottom of this node tree. I want the dinosaur to always appear in front of everything. So first of all, I'm going to move him back to the position that he was at. I'll just undo these steps. And then I go into the dinosaur scene, which should be inside my scenes folder. And on the parent node, there's a property which is called ordering. I'll change the Z index to 1. This will mean that it's always drawn on top of everything. Now let's add in some code to give the player controls. We'll go into the Dino node, and up here I'll click to add a new script. The script is mostly blank, but it extends the character body 2D node, which is what this one originally was called. To add jumping into the game, we need two forces. One that pushes the player up, and one that pulls the player back down. And that's going to be our jump speed and the gravity. At each iteration of the game loop, we want to apply these forces to our dinosaur, and that's going to be done inside a physics process function. We increase the dinosaur's vertical velocity, velocity y, by the gravity. Jumping is going to be done by pressing the spacebar, and we can check for that as an input. When the spacebar is pressed, we apply the jump speed onto our velocity value, and at the same time, we play the jump sound. To move the dinosaur and to handle the collision, we call Godot's move and slide function. This jump sound is going to become annoying, so for now I'm just going to comment this out. And if I test this game and I press spacebar, you can see the dinosaur jumps and falls back down. There is one issue though, which is that if I hold the spacebar, then he just keeps jumping. So what I need to be able to do here is only jump when the player is on the ground. And Godot has a built-in check for that. I'm going to put it right at the start here, and it's going to check is on floor. If it is, then I want to be able to jump, but otherwise I'll just fall back down. If I run it again and I press spacebar, it only jumps once. So if I hold the spacebar, it just keeps jumping every time it lands back down on the ground. But you might have noticed that the animation never changed, and that's because we never told it to. So at this point I'm going to add an else statement. So if the player is not on the ground, then I want to change it to the jumping animation. The other action apart from jump is going to be duck. And that's going to happen when the player presses the down key. So we can check for this at the same time. If that happens, then we simply run the duck animation. And lastly, if none of these keys are pressed, then we want to play the run animation. If I run this game now, we start off with the run animation. Of course, the player isn't actually moving anywhere, but you can see that it changes from running to jumping. And then if I press down, it now changes to a ducking animation. So all three are working correctly now. Another thing I want to do in the code is to be able to toggle these running and ducking collision shapes on and off depending on what the player is doing. And we can actually visualize these if we go into debug and visible collision shapes. If I run the game now, you can see the collision shapes here. So you can just about make up the difference between the two here. So you've got the running one that's a bit taller than the ducking one. What I will do is begin by saying that the running collision shape is not disabled, and I'm assuming that we are running. But then if I press the down key and we change to a ducking state, then we disable the running collision. And if I run this now, you can actually see that. So the color here is going to change when I press the down key. It changes to this kind of orangey color. And that's just to signify that that collision shape is no longer active. When I let go of the down key, it activates again. And now we can begin creating the obstacles. Each one is going to be an Area 2D node as the parent, and then inside that is going to be a Sprite 2D node. This first one is going to be a stump, so I'm going to change the name of the node accordingly. Then we go into our sprite, and I'll drag over from the obstacles folder the stump image. It's a little bit small, so I'm going to change the scale to 4 times, and then to get rid of that blurriness, again we go into texture and change it to nearest instead of inherit. I still have this warning label up here which says that there's no collision shape. I'm not going to manually create one though, because the shape of this is a little bit awkward. What we can actually do is go up to sprite up here and create a collision polygon sibling. This will try to work out the size of the image and create a polygon for this collision shape. I can modify it a little bit though, because you can see it's kind of mixed some areas, and also it doesn't need to be super accurate. So I can just get it to capture the outer limits of this image, and that'll be close enough. Now I can just save this scene with the other ones, and that's the stump completed. There's two other obstacles. There's the barrel and the rock, and they will need scenes created just in the same way. So try it out and see if you can create those ones yourself. When you're done, you should have the stump, the barrel, and the rock scenes. The rock image is a little bit bigger than the others, so for the scale I actually used 3 instead of 4. And for the barrel polygon, well, you didn't really need a polygon because it's a square, so I actually just used a rectangular collision shape here. There is one more obstacle, and that's the bird, and it's a little bit different to the others. It's an animated sprite for one, but also the shape of it is a little bit different. Based on what I've covered so far in this video, you should be able to put this together yourself. So have a go at it, and then I'm going to go through what I've actually configured. Now this node here is area 2D, just like the other obstacles, and I haven't really changed anything there. Then I created an animate sprite node, added a flying animation, and using the tile set, I picked out the first 4 frames. I changed the frame rate to 10 frames per second, and I set this one to autoplay on load. The image was also a little bit small, so I scaled it up to 4, and then texture was a bit blurry, so I changed the filter to nearest. That was it for the animated sprite, and then I had to create the collision shapes. I wasn't able to automatically generate a polygon because this isn't an individual sprite node, so I created these 2 collision shapes. The first one is a rectangle, like we've already done previously, but the second one I haven't used yet, and it's a capsule shape. It allows you to create an oval shape instead. We can leave the obstacles and move on to the next part. Back over on the main scene, I can now add in the script for motion. I go up onto the main node and click this button to add a new script. I'll begin by defining a couple of variables right at the top here. These are going to be constants, and they will be the start position for the dinosaur as well as the 2D camera node. After that, I define a couple of speed variables. This is how fast the dinosaur is going to move across the screen. I'll define the start speed as a constant, and then a variable for the changing speed as the game gets more and more difficult. I also define a maximum speed so that the dinosaur can't go too fast. Now I can begin creating my functions. Down here, I'll create the new game function. One of the things this function will do is reset everything back to its starting coordinates. So here we take our dinosaur node and we set the position back to the start position variable from here. I do the same for the dinosaur speed, the camera position, and the ground position. I need to make sure that I call this function as soon as the game is run, so that goes inside the ready function. I execute the game just to make sure that everything is positioned like it should be. The actual game logic happens inside this process function here. The first thing I'm going to do is take that start speed and assign it into my current speed variable. I can then use that speed variable to move the position of the dinosaur and the camera. By increasing their x coordinate, I'm effectively moving both of them to the right all the time. If I run this now, we can see the effect happening. So the dinosaur runs across the screen, our background is working exactly as it should, it's an infinite scrolling parallax, but you will have noticed that the ground eventually went off the screen and the dinosaur fell down. We need to make sure that we also move the ground along with everything else. So for that, I need an additional variable. I'll go back up here and I'll define a variable called screen size. Then inside our ready function, as soon as this node is loaded, we calculate the screen size from our game window. I can now use this to see how far we've scrolled. Back in my process function, I will add a comment to say update the ground position. This will check if the camera's X position minus the ground X position is greater than 1.5 times our screen size. It basically means that the camera has moved on too far and now the ground is about to go off the side of the screen. If that is the case, then all we do is just shift the ground along by the width of the screen. If I execute the game again, we can see that the ground just continues to scroll. But what's effectively happening is that when the right edge of the ground gets to the right edge of the screen, that's when we trigger that if statement and we reposition the ground back over on the left. As the dinosaur runs across the screen, I want him to earn points, so the score increases the longer you can run. I need a variable to be able to track this, and that's going to be our score variable. inside the new game function, before we reset the nodes, I want to reset the variables. The only variable that I'm using for now that needs resetting is the score variable, and we set this to 0. Then, back inside my process function, once I've moved the dinosaur and the camera, I can now update my score. So I will take the speed variable and I will add it to the score. To see this working, we can just print this out for now. If I run the game again, we can see down here the score is very quickly increasing as the player runs across the screen. This isn't a very good way of showing the player's score though. I would like it to appear on the game instead, so somewhere on the top left I'd like to show the score. For that we're going to need a new scene. I'll switch back over to the 2D view and set up a canvas layer node. This node is used for heads-up displays as it's always shown on top of everything else. So I'll rename that to HUD and I'll set up my text. Text can be done using labels, so I'll add that as a child node. I'm going to have a few labels, so I'm going to rename them accordingly. This first one is going to be the score label. I need to add some temporary text into it, so it will say score. Then I adjust the alignment to center. I can also go down into theme overrides, look for fonts, and I can change out the font. So down here in my assets, I've actually got a font that I would like to use. Then I can set the font size to something a little bit bigger than this. And now we've got the score coming up. A handy way of positioning things on the screen is to use these anchor presets. So you can put something in the top right, in the middle. In my case, top left was okay, so I will stick with that one. There are a couple of other labels that I want to add to this heads-up display. Now using this same approach, try setting up your own labels for the high score, as well as text in the middle of the screen that says press space to play. When you're done, your note tree should look like this, and your game window should have these labels in it. All three of them are exactly the same, the only difference is the text they contain as well as the positioning, for which I use these anchor presets. Now we can save this scene inside our folder and go back into our main script. Back inside the main script, just after we update our score, I'm going to call a function called showScore. We will need to define this function, so I will go down the bottom here and create a new function which will update the score text. But before I can do that, I need to link that scene into my main scene. So I go up here again to instantiate and I pick up my heads-up display. Now I can access that heads-up display. So I'll drag it down, but what I actually need is the score label inside it. So I need to go down one more level. And to do that, I use the getNode function. This looks for the score label node inside our heads-up display scene. I access its text property and I will set it to display our score. Because the score is an integer, it has to be converted into a string first. And if I run the game, we can see the score up here in the top left increasing. I think it goes up a little bit too quickly though, so I would like to add a modifier to this to divide the whole thing by 10. I go all the way back up to where I'm defining my variables, and just underneath the score variable I add a new one called score modifier. I can now use that variable when I'm displaying my score. So instead of just showing the score variable, I say it's score divided by that modifier of 10. Running it again, we can see the score goes up at a much more reasonable rate. Another thing that I would like to fix is that the dinosaur shouldn't start running immediately. I would like to wait for the first player input before the game really begins. And for that, I will create another variable at the top here, which will be called gameRunning. I can use that variable inside of my process function to check if the game is running. And if it is, then I'm going to execute all of this code. So I indent all of it inside. But if the game is not currently running, then I have an else statement, because this means that we've just launched the game and we're waiting for the player to press the spacebar. So I'm going to look for that as an input. Once we get that input, I set that variable over to true. If I execute the game now, you can see we start off, we have got this running animation playing, we'll fix that in a second, but the dinosaur isn't running and the score isn't being updated. Once I press the spacebar, everything begins properly. This text though should disappear as soon as we press space, so let's add a line to take care of that. I already showed how to access a node of a child, so when we went into the score label we went down 2 levels. Now I'm looking for the start label, and that's going to be done in the same way. I use the get node, look for start label, and then I just hide it. But if I hide something, then I need to make sure that I also show it whenever we have a new game started. Right at the bottom, after I reset my nodes, I'm going to reset my heads-up display as well. Let's run that again, and this time as soon as I press space, that disappears and it feels more like the game is beginning properly. But before the game does begin, the score isn't displaying anything. even though we set the variable to 0 right at the start of the game. And that's because we aren't calling that update function. So now if I run the show score function, it will update that node to show the actual variable. And before we move on to the next bit, let's just fix this issue with the animation. The dinosaur starts off with a running animation. If we go into our dinosaur scene, we can modify this behavior. The dinosaur has an idle animation, but it doesn't have an idle state here. And that's because the game running variable that we use in the main script doesn't appear in here. There is a way for us to pass it through though. So just inside this if statement, I'm going to add another line which looks for the game running variable from the parent. This allows us to get any variable from our parent node. And I'm saying that if this variable is not true, then I want to be in an idle state. But if the variable is true, then I want to execute this section of code just like I was doing before. Make sure that this jump animation though and this else statement doesn't get indented when you do that. This part is separate, and that's in line with this first if statement that checks if the player is on the ground or not. This section here that we've passed for now, well, that's going to be our idle state because the game hasn't started. So we can copy over one of these lines and replace the animation name with idle. If I run the script now, the dinosaur starts off with an idle state. As soon as I start the game, he switches over to the running animation. And that's the dinosaur scene finished, so we can close that one down, as well as the heads-up display, and go back into our main script. Now I would like a way of increasing the game speed the further you go. To do that, I will update the speed variable inside of our process function. Currently, I'm just setting the speed to our starting speed, but I'm going to add onto that our score divided by a very large value because the score increases very quickly. So I'm going to set a value of 5,000, but I don't want to add arbitrary numbers into the code. So instead, I'm going to define this as a variable. And that will be the speed modifier. That variable hasn't been defined yet, so we scroll back up and look for where we've defined our speed variables and add this one to it. This will allow the game to increase in speed as we progress. So I can print out the speed variable down here and I run the game. Then as soon as the game begins, we can see that we start with a speed of 10, and that was our starting value. But when we get to score around about 500, that increases by 1. The game is going to continue getting faster and faster, and eventually it will get to a point where it's just too fast to play. I will need a way of limiting the speed, and that's where that max speed variable from before comes in. And this section of code here will limit our speed to the maximum speed allowed. Now I can finally begin generating the obstacles. So far with the other nodes, I've been able to instantiate them and link them into this scene here. But for the obstacles, I won't be able to do that. Instead, they're going to be generated in the code. So I need to preload them inside of this script. Right at the top here, I'm going to preload each of the scenes. I assign them to variables. So for example, the stump scene has its own variable, and then I find the location inside this folder structure here. So that scene is inside the scenes folder, and it is down here. Then I simply repeat the process for my other 3 obstacles, which includes the bird. And then I group them together inside of an array to make it easier to work out which one is which. Notice that I don't add the bird into this array because the bird is generated slightly differently and it behaves a little bit differently to the others as well. I then need an array to track the obstacles that I've already created, and then finally I will define another array which has the heights at which the bird will spawn. So just to add a bit of variety, the bird can spawn either high up in the game or just above the player enough that he has to duck to avoid colliding with it. With those preloaded and set up, there's one more game variable that I need to add at the bottom here, and that is going to be last obs, and this will just track the last obstacle that's been created. Now I can begin creating the obstacles. This will be done in a separate function, and that function will be called generate obstacles. I'll call it from inside of my process function just after I adjust the score. So right at the top here, before I move the dinosaur and everything else, I'm going to call this new function generate obs. So then we'll go down here and create this new function. The 3 stationary obstacles will behave slightly differently to the bird. So the ground obstacles will have their own logic first. I chose not to use a timer to create these. Instead, I have to first of all create an obstacle as soon as the game begins. That's going to be done by checking if that obstacles list is empty. So if there's nothing in it, then I can create something. I then have to pick the scene that I want to use. If I go back up here, I have got all of these 3 scenes, minus the bird, stored inside of obstacle types. So to add a bit of variety, I'm going to randomly pick one of these and generate that one. So that's what I'm going to do inside this function next. I'll pick an obstacle and I'll assign it into this obstacle type variable. I'll then create a new variable, which will be the actual obstacle instance itself. Then I can instantiate the obstacle type and I will save it into my obstacle variable. Once that's created, I save it inside the last obstacle variable so that I can track the last one that I made. Once all of that is done, I add that node as a child of my main scene, and I also include it inside the obstacles array. But if I execute this now, we don't see any of the obstacles, and that's because they aren't being positioned anywhere visible. So we need to define their x and y coordinates. And this is where it gets a little bit tricky, because I need to be able to position the obstacles right on top of the ground. And to do that, I need to know how tall the ground is, as well as how tall the obstacle image itself is. So there's some information that I'm going to have to pull from these nodes. For a start, now that I've created an obstacle instance, I can access all of its properties. This instance could be any one of these scenes. So for example, if we open up the stump scene again, we've got properties inside it. We have our area 2D, a sprite, and a collision polygon. I can access all of that information inside of my main script. The first thing that I want to get is the height of the obstacle. And I can do that by going into the sprite 2D node, getting the texture and asking for its height. But the images are scaled and they're not all scaled in the same way. So I also need to get the obstacle scale. And that gives us the information about the obstacle image. But what about the ground? I need to know how high up or how tall that ground image is. I'll go back up here, and just after I get my screen size, I'll add another variable for ground height. Our ground is a node here, and this also has a 2D sprite inside it. So just in the same way, if I go into my ready function, just after I get my screen size, I can get the ground height. So I access the ground node, then I go into its child node of sprite 2D, look at its texture, and get the height of that texture. And now that I have all of that information, I can finally position my obstacle at the correct place. Just after I work out the height and the scale, I'm going to work out the x coordinate. This will take the width of the screen plus the score, because the game is constantly moving to the left, and it will add a little buffer just to make sure that the obstacle appears on the right of the screen and then moves onto the screen. Otherwise it will just pop onto the screen and it will look kind of weird. We've got the x coordinate, and now we can do the y coordinate, which is a little bit more to it. Again, we take the screen height this time, we take away the ground height, so that gives us just a space available above the ground. And then we need to work with the obstacle height and its scale to work out how high up it needs to be on top of our ground. Then I just need to add 5 pixels just to offset it a little bit. And now that I have these variables, just after I create my obstacle, I can assign its position based on obstacle X and obstacle Y. If I test it out again and I start running, you can see straight away I got this barrel appearing. So it was the first obstacle created and it appears just off the screen. So as soon as I start running, you can see it slide into view. So that works, but the code is getting a little bit messy. So to tidy it up, I'm going to create a separate function down here called add obstacle. Then I can take these last 3 lines from here and I can move them into this function instead. I just adjust my indentation, and then I need to tweak this section here because I'm no longer working with OBS X and Y. I just have X and Y passed in as arguments. Now I can call that function in here once I've created my obstacle. If we test this out again, I should have the same result as before, but now the code is a little bit more reusable. But how do we create more of them? So right now I only have 1 appearing, and then once it goes off the screen, that's pretty much it. Right now they're only being generated if the obstacles array is empty, but as soon as we create 1 obstacle, we add it to that array, so this never runs again. I need a second variable here, or a second condition, which is going to be an OR statement. And this is where that last obstacle comes in. So instead of using a timer to generate these obstacles, I look at where the current obstacle is. So if I create an obstacle and it gets to maybe just past the middle of the screen, then I want to get another one created at the back of it. So that's what's happening here. I look at the position of the last one, and if that's less than the score plus a random number between 300 and 500, then we want to create a new one. So why have I added this random range here? Well, without this, each obstacle would appear at fixed intervals. So just to randomize the spacing between them a little bit, I've added this random range. If I run it now, we should be able to get obstacles. So as soon as that one goes to about here, a new one appears right in behind it. I'd like to add a bit more variety to it though, so that rather than generating one individual item each time, sometimes they will appear as little clusters. So for that, I need to create another variable up here, which will be the max obstacles, and I'm going to set that to 3. Then I'll add a for loop, and this for loop is going to be based on this max obstacle variable. So it will range in between 1 and 3. Then I indent all of this code inside the for loop, but if I run it now, nothing will change, because each of the obstacles is still positioned in the same place. So even if I create 3 rocks or 3 barrels, they all align in the same position. So I need to space them out inside this obstacle x variable. I will do that by adding a 100 space multiplier based on how many of them I'm making. Now if I run it again, you can see we've created 2 rocks, another 2 rocks, 3 barrels, and it just adds a little bit more randomness and variety to the game. And this isn't something that I want to start from the beginning though. I actually want the number of obstacles to begin as 1 as the game starts and then increase as it gets more difficult. So I'm going to add an extra variable right at the top to control this, or rather 2 variables. One is going to be the current difficulty and the second will be the maximum difficulty. This way the difficulty can increase as the game progresses. I need to define my starting value for difficulty as 0, and then I need a way of adjusting it, so as we progress through the game and the score increases, we want that difficulty to go up. So I'll add a function right at the bottom here. This will be called adjust difficulty. It's going to take the current score and divide it by the speed modifier that we defined earlier. This, however, could allow the difficulty to increase too much. So I want to limit it using that max difficulty variable. I still need to call this function though, and that will be done inside of my process function. So right at the top here, I'll add a comment to say speed up and adjust difficulty. Once I have adjusted the speed, I will call that function to also adjust difficulty. I can now use this inside of my generate obstacle function. Right now I'm setting the maximum obstacles to an arbitrary value of 3, but instead I can set it to difficulty plus 1. That way it's going to range between 1 and 3, and as we progress through the game, we'll generate more and more of these obstacles in little clusters. We can run the game to test this out. So at the very beginning, we should only have 1 obstacle appearing at a time. And this will continue until the difficulty increases at score 500. From this point on, it could be between 1 and 2 obstacles. So you can see that we had 2, 2 and 1, and then a couple of 2s. If I keep going now, the difficulty is increased again. And now there's a real variety between 1 and 3 obstacle bunches. What we haven't done though is add in the bird. So right now all we have is the 3 static ones that sit on the ground. But we want to add in the bird as well. I'm going to add a random chance to generate a bird. So we still run this code as normal and we create our obstacles, but there's also going to be a random opportunity to spawn a bird. The bird is something that should come in a bit later on in the game. So it's only going to happen when difficulty has reached the max difficulty. Then I will choose a random number and I'll divide it by 2 to see what the remainder is. This basically will give me either a 0 or a 1, so there's going to be a 50-50 chance of generating a bird. The code for this is similar to what we've already done for the stationary obstacles. We first of all instantiate it as an obstacle variable, then I define an x coordinate for it based on the screen width, the current score, and then add a 100 pixel buffer so that the bird comes in from the right hand side. I then define the y coordinate, and that one comes from that bird heights array. So I pick a random value and that will mean it either comes in low or it comes in higher. Once I have those variables, I can call that addObs function that I created earlier to create this new bird obstacle. I won't be able to test this right away because it will only come in when I move to max difficulty. So for now, I'm going to get rid of that check and I will just say is difficulty equal to 0, and I will comment that out just to see that we're actually generating these birds correctly. So at this point, there should be a 50-50 chance of generating a bird. Right now, I haven't had one, but there you go. So we've now appeared with an obstacle and a bird directly above it. You will have noticed though that the bird doesn't move, it just kind of sits there in its static position. We actually need to add a little bit of code to the bird scene. So the other obstacles are okay, I'm going to close them down, but the bird does need to add a script. So I go back into this parent node, click this button to add a script. And it's going to be just one line. We go inside the process function and then we adjust the bird's position based on the speed variable in the parent node, which is our main game node. So essentially I'm going to move the bird left using this minus across the screen, but not at the full speed, because then it's just going to be way too fast, because the player is moving to the right and the bird is going to move to the left at the same speed. So instead I halve the bird's speed. That way it does have some movement, but it's just not as fast as the player. So if I test this out again, now you can see the birds are coming in, and because we have that movement on them, it just looks a little bit more natural. They're not just stuck flapping their wings in the same position. So now the obstacles are working pretty well. There is one thing that isn't immediately obvious though, and that's that once the obstacles go off the screen on the left hand side, they don't disappear. They're still there in the game, and that bird is still flying to the left. So we need to clean that up, because as the game progresses, we're just going to have a whole bunch of items in memory that have long gone off the side of the screen. We go back inside of our process function, and just at the bottom here, once we've updated the ground position, I'll add a little section here to remove the obstacles that have gone off the screen. This is where that array from earlier comes in useful, the obstacles array. I iterate through that one and I pick out each individual obstacle. I then look at that obstacle's x-coordinate, and if it's less than the camera's position, so it means that if it's gone off the side of the screen, then I need to delete it. I don't have an easy function to do that, so I'm going to create my own, and that's going to be called remove obstacle. I pass in the obstacle into that function and it will clean it up for me. So now we need to define this helper function. Well, I already have an add obstacle function up here, so I'm just going to create this one right underneath it. Remove obstacles. This needs to do two things. First, it has to remove the obstacle instance or the node from our main node scene, and that's done by calling queue_free on the actual node. But I also need to remove it from that array. So I take my obstacles array and I erase that obstacle from it. That tidies up our obstacle generation pretty well. But one big thing is that I can still run through all of these. We don't actually have any collision detection. To understand how this collision check will work, we have to look at one of these obstacle scenes. If I open up the stump, we have the stump node set up as an area 2D node, and that has a bunch of individual signals. One of the signals that we're interested in is body entered. So this signal will emit whenever a body, in our case our character body, moves into the area that we've defined with a collision polygon. So if our character body, which is a dinosaur, moves in here, then it's going to trigger that signal. It won't only be looking for this dinosaur though. There are other objects on the screen and in the game that will trigger this method. So we will need to filter all of those out. But the important thing to note is that this is the function or the signal that we're looking for. The challenge that we're going to have is that we don't have that node inside this tree. So how do we access that signal? Well, that's going to be done by connecting to it from the main script. Inside our add obstacles function, where we first generate them, once we've created it, I'm going to connect into that signal. This line basically says, look at that node, find the body enter signal and connect to it. But inside these brackets, I need to add a function, and that's going to be the function that triggers whenever this signal is emitted. This function doesn't exist yet, so I'm going to create a new function and I will call it hit_obs for obstacle. And now I need to define it, so we'll just do it down here. We define this hit obstacles function, but importantly inside it, we have to add in the body that we've checked for collision with. I got stuck on this for quite a while because I didn't put anything into those brackets when I was making this game. So I have to give credit to the guys over on the Discord channel for helping me figure this one out. So we pass in the body, then I can check the name property of that body and compare it against the dinosaur. Well, my dinosaur node is called Dino, so that's what I'm checking for. But if you were making a different kind of game with a different player, you would need to make sure that this here matches whatever your character is called. So if that is the case, then it's a dinosaur that has come in contact. So for now, I can just print collision. And if I run this code and say I run into this obstacle, you can see it's detected it straight away. So every time we come in contact with something, whether it's the bird or one of the static obstacles, we're picking up the collision. What we need this to do is to trigger some kind of game over function. So we'll define that just now. I'll call a game over function from here, and then I will go down and create it below. So we'll say function game over, and the first thing I'll do is pause the whole game. And I will also set the game running variable to false. Now if the dinosaur runs into any obstacles, the whole thing freezes up. So that's partially there, but I have no way of restarting the game. For that I need a game over scene. I've created this scene here, and it's quite similar to what we've already done. I have my canvas layer for the game over node, and then I've added a button node as a child, which we haven't used yet. For the text, I've put in restart. Then to position it and to size it accordingly, I've gone into layout and transform, and set the width and height to 250 and 55. I didn't position it like this, I just used the center preset. And lastly, I just changed the font size, and created texture styles for the different conditions of the mouse. To create one of these, you just click on one of the empty spaces, new style box flat, click it again, and then you can change the color to whatever you like. Now, I don't need this one, so I'm just going to clear that out of here, and I will only use normal, hover, and pressed. There's no script with this, so you can just save this scene and we can close it down. Now we can instantiate it inside of our main scene. So we'll click on that link and pull in the game over. It comes up straight away with the restart button being shown here, but we will hide that inside of our script. To hide it, we go into our new game function right at the top, and just after this line, we hide the game over scene. I'll also update this comment to reflect that. So we hide it at the start, but we need to make sure that we show it when we have a game over condition. So if I run it now and we run through and hit an obstacle, it now pops up. We can hover over it, but clicking doesn't do anything. We aren't actually connected to this node. So in the same way as the obstacles had a body entered signal, this button also has its own signals. So if I open this back up and we go into the button and switch over to node, there's the button press signal. That's the one we're interested in. So I need to make sure that I connect to that as soon as we start the game inside of this ready function. So before we have the new game function, we'll connect into that button node and we trigger the new game function from it. So now this new game function will be triggered at different times. First it will be when we run the game, but then anytime we have a game over condition and we press that button, we will also trigger the new game function, allowing us to reset everything. So let's try this again, run into an obstacle, click restart, still nothing happens. And that's because we've paused everything. So right now the entire game is paused, but we don't want that to apply to our game over scene. So we go into this process tab and change the mode into when paused. Now the game over scene only works when the game is paused. So if I run along, come in contact, and I click it now, we have this partial reset. Not everything seems to have worked though, and that's because we haven't unpaused the game. So right at the top here, before I set the difficulty, I'm going to unpause the game. Run it again, run into an obstacle, and hit restart, and now everything is back to where it was at the beginning. I can start playing again, but you may have noticed it's the same obstacles. Restart again, and there's that bird that I just ran past. Restart, and there it is again. So what that's telling us is that while we're restarting the game, we're not restarting the obstacles. They're still there from before. We need to make sure that as part of this new game function, we reset all of our obstacles as well. We'll do that by iterating through that obstacles array, cleaning up each of the nodes by calling Q3 on them, and then once we're finished with that, we clear the entire array. So let's try this again, and I'll run along, hit that barrel, and there's a bird coming over as well. If I restart, that may have just been luck that I got another bird there. And maybe again. Okay, it seemed like something went wrong, but it was just bad coincidence that the bird seemed to be appearing each time. But now we can see that it's coming in slightly differently in each iteration. And we're nearly done. There's just a couple of things to tidy up. The first one is we temporarily commented out this section here when we generate the birds. So we're going to get rid of this and put it back to how it should be. So the birds are only generated once we reach the max difficulty. But the other thing I want to do is add in this high score. So right now nothing actually happens. When we die and restart, the high score is always just nothing. I firstly need to create a new variable for this. So I'll do it right at the top here, and then I can generate a new function. We'll go right down here, and just after we have a function for showing the score, just to keep them together, we'll also check for the high score. Well, first of all, we take the current score and we say if it's greater than the high score, then we can update the high score to match. But we also need to update that label, which is inside our heads up display node. So just like we did with show score up here, I need to now access the high score label and update it to show the new high score. Now I just need to call this function from somewhere. And the only time I want to check for the high score is when the game is finished. So basically we look at the score at that time and we compare it to the current high score. So I'll add it right at the bottom here. And if I test the game out again, I currently have no score. But now as soon as I've died, the high score is going to 101. If I can get a little bit faster and further than this time, the high score updates to 182 now. And that's it, we now have a fully working Dino game. So I hope you found this useful, and if you did, please leave a like, and I'll see you in the next video.